Hello everyone. Uh, Today I am going to present the topic principal stresses in aircraft windshield and panels. Where does the stresses orient or originates? Aircraft windshield endure a complex interplay of force. Understanding their origin in critical for structural integrity. Where now we see where the stresses or stresses occurs or load is applied due to airflow, cabin pressurization. Due to cabin pressurization, internal pressure creates significant in plane membrane stress, pushing the panel outward. Due to there is a pressure inside is higher than outside, so it push the panel outward. Second is aerodynamic load, external pressure and suction from airflow inducing sub sustain substantial bending stress. External pressure like pressure due to airflow, this exert pressure on the windshield, which create bending stress. Third is temperature gradient. Uneven heating cooling leads to thermal stresses, adding to the in plane load. Means due to airflow, friction is happen in the windshield and the air flowing air. Due to this friction, temperature is increasing and uh, there is a uneven heating. Third is frame constraint. The rigid attachment to airframe induce critical edge stresses as the panel tries to expand. Which are the major principal stresses? Major principal stresses are tensile, tangential to the wind edges, hop direction. Which are the minor principal stresses? Lower tensile or compressive radial direction toward the frame. Second, defining principal stresses. Principal stresses represent the maximum and normal stresses at a point where shear stress is zero. For aircraft windshield, these are the typical major principal stresses. Nature typically tensile direction, circumferential to panels perimeter. Primary source internal pressurization and thermal expansion, resident by frame. These stresses is critical for resisting outward bowing and cracking. Now minor principal stresses. Nature usually compressive or less tensile. Direction radial from the center outward toward the frame. Prime source in influenced by aerodynamic suction and bending, which can reduce its magnitude or make it compressive. Note: through thickness, bending stress is not an in-plane principal stress, but it vital for assessing uh, delamination and interlayer cracking in laminated planes. Now, Stress component is solid mechanics. At any point on the panel given determining principal stresses. At any point on panel given the local surface stress, we can mathematically derive the principal stresses. Local surface stresses. Normal stresses along two orthogonal direction, uh, sigma x and sigma y. In plane shear stress sigma xy. Principal stress sigma x sigma y are obtained from 2D stresses transformation equation. Sigma 1 is equal to sigma x plus sigma y divided by 2 underscore sigma x square plus y square divided by 2 plus sigma x. These equations locate the panels through shear stress is 0 and normal stress are extreme. Interpretation principal stresses direction means interpreting the direction of the stresses. Principal stresses are key indicators for critical and path and potential failure points, particularly in anisotropic material or complex geometries. These directions are fundamental because they are represent planes of pure tension or compression, where shear stress is inherently zero. Maximum principal stresses, typically tangential hook in aircraft windshield due to dominant effect of internal pressurization. Second is on the curved panel geometry. This is the primary stress driving potential crack initiation. Minimum principal stresses typically radial, chordwise. Its magnitude and sign are highly crucial. The principal stresses calculation these ensure a compressive stress state is analyzed. Second, physical significance of aircraft windshield. Understanding the physical manifestation of principal stresses directly inform design discussing for safety and longevity. The minor stresses and the major stresses. Minor stresses. These stresses is of lower magnitude and often acts in the radial direction perpendicular to sigma I. It can be tensile or compressive depending on the specific loading condition impact. These two in plane principal stresses are primary derived for crack initiation and subsequent propagation or within the glass or polycarbonate layer of windshield. Their accurate determination is paramount for predicting structural integrity and fatigue life. Major principal tensile stresses. These stresses typically runs around the pri- pre- perimeter of windshield, aligning with the circumstantial hook direction. It represents the highest tensile force the material experience in its plane. Simplified Beyond example. Here we get one example beyond 747 windshield. Let's illustrate calculation of stress using typical parameter for large aircraft windshield. Here we assume combined cabin pressure differential 60 kilopascal, panel thickness is 0.02 meter, and panel radius is 0.5 meter. Membrane stress. A membrane in a membrane for calculating stress or due to pressurization, we have formula P into C into R upon 2T. Here the P is the cabin pressure, and divided by 0.5 into 2 into 0.02, that is a membrane pressure is 0.75 megapascal. These represent the initial in-plane tensile stress due to internal pressure pushing outward the curved panel due to pressurization. Cabin stresses final principal values. To get a material picture, we superimpose the aerodynamic bending stresses onto the membrane stress. Aerodynamic load assumptions. Aerodynamic pressure, we assume aerodynamic pressure 10 kilopascal, 0.01 megapascal. Bending stresses simplified. We can approximately bending stress for simplified supported curved panel. The resultant principal stress, after accounting for both membrane and bending effect and considering typical edges condition and material behavior, the calculated principal stresses would be major principal stress plus 2.6 megapascal, nature tensile, location concentrated around the window edge, primarily in the hoop direction. This is the stress most critical for crack propagation. Minor principal stresses are minus 0.02 minus 1.2 megapascal. Nature compressive location in the radial direction. The compressive nature often result from the combination of outward pressure and inward pulling aerodynamic suction along with frame resident. This example highlight the complexity of stresses state in aircraft transparency under scorping the need of detailed finite element analysis in the real world scenario. So thank you for your attention, and I hope this is clear for you. Thank you.